Let ABC be a parallelogram with angle BAD less than 90 degrees. A circle tangent to sides DA, AB, and BC intersects diagonal AC at points P and Q with AP less than AQ as shown. Suppose that AP is equal to 3, PQ is equal to 9, and QC is equal to 16. Then the area of ABCD can be expressed in the form m root n, where m and n are positive integers and n is not divisible by the square of any prime. Find m plus n. Okay, so the first thing I'm going to do before we get into any math is decorate this diagram a little bit. So what I'm going to do is I'm going to draw this point O, as well as the radii to the points of tangency on the three sides. So I'm going to draw this one, and this one. And we're going to call these points, let's see, X, Y, and Z. And one thing you should notice is that segment OX is perpendicular to BC, segment OZ is perpendicular to AD, but AD and BC are actually parallel. So OX and OZ must actually have the same direction, so they must actually be the same, they must be on the same line. So OX and Z are actually collinear. And that's really nice, and we'll see why in a little bit. Another few things I'm going to add is I'm going to add perpendiculars from C to AD and A to BC, and then you might have to extend out the side lengths a little bit. So I will draw these perpendiculars, and we're going to call these points, we'll call them E and F. And one important thing to note is that because this is a parallelogram, it's pretty symmetrical if you rotate it 180 degrees. So EB is going to be equal to DF, and AE is going to be equal to CF, which you'll notice is equal to the height of this parallelogram, so it's also going to be equal to XZ. So what are we going to do now? We are going to start playing with the numbers. We have AP is equal to 3, PQ is equal to 9, QC is equal to 16, and we want to find the area of parallelogram ABCD, which I will highlight in red. And to be able to find the area of this parallelogram, we are going to need to apply our formula for area of a parallelogram, namely area is equal to base times height, So our base is going to be side length AD, which is also equal to BC. Your height is going to be equal to CF, which is equal to AE, which is equal to XZ, the height of this parallelogram. So we're going to need to be able to find both of these. Now, first thing I'm going to do is I'm going to find the length of the tangents because, well, we have a circle that's tangent to a bunch of sides, so it makes sense to find some of the segments we can find. I'm going to color AZ and AY green by the law of equal tangents. Since AY and AZ are both tangents from point A, they are equal to each other, which is why I'm highlighting them both green. So we're going to find that. We're also going to find the length of CX, which is the tangent from C to the circle. And I'll leave BX and BY. I will leave them red because we'll come back and find those later. It's going to take a little more work to find those. So let's get to work by finding length AZ or AY. And what we're going to use is we're going to use the power of a point theorem. I'm going to abbreviate it POP, which states that in any circle, if you have a point, and then I draw this and I draw the tangent over here, then let's give these points names. We're going to call them A prime, B prime, C prime, and D prime. Power of point theorem states that A prime C prime times A prime D prime is equal to A prime B prime squared. And that's exactly what we're going to use. So in this case, we have AP times AQ is equal to AZ squared. That's in our main diagram with the parallelogram. You have AP times AQ is equal to AZ squared. So AP is equal to 3. AQ is equal to AP plus PQ, which is 3 plus 9, which is 12. So this is equal to AZ squared. which is equal to 36. So AZ is equal to 6. Similarly, AY is equal to 6 by the same thing. You can also find CX by using power of a point, because power of a point gives CQ times CP is equal to CX squared. CQ is 16. CP is 16 times 9, 16 plus 9, excuse me, which is 25. So this is 400, which is CX squared. So CX is equal to 20. And that's cool, but that doesn't seem to be helping us get any closer to finding the area of this parallelogram, because we needed to find this whole base and this whole height. So what I'm going to do is I'm going to actually call this length, I'm going to call it x, and I'm going to call by x as well, lowercase x. And if we can find the length of x, you can find the length of the base. But how is that going to help us find the length of the height? And how are we going to be able to find x in the first place? We'll deal with the first question first. How do you find the height? And the way you do that is, well, first of all, I'm gonna mark down a few sides. These 4 side lengths form a rectangle, and the reason is because what you have is this is a right angle, you have this is a right angle, and you also have this is right angle and that's a right angle. So that is a rectangle, which means that this side FZ is equal to the opposite side CX, which is equal to 20 as well, which means that entire side AF is equal to 6 plus 20, which is equal to 26. You also have this big length is equal to 3 plus 9 plus 16. So let me write this down. AC is equal to 3 plus 9 plus 16 is equal to 28. And how is that going to help us? It's going to help us because we have a right triangle. And I'm going to mark this right triangle in blue. This right triangle, CFA over here, has side lengths 28 and 26. And guess what? The other leg is our height. So we can actually find this height. By Pythagorean theorem, you must have 26 squared plus h squared is equal to 28 squared. 26 squared is 676. H squared is, well, we'll find out, and 28 squared is 784. Rearrange h squared is 108. So h is the square root of 108, which you can simplify to 6 root 3. So that's great. We found our height, 6 root 3. Now we need to find our base. So I am going to get rid of the colors over here, and I'm going to see what we can do to be able to find our x. Well, if we find our x, we'll be able to find the length of this whole base. So I'm going to mark this as 6 root 3. Okay, so we had some success with the Pythagorean theorem. So why don't we try a different right triangle? And this time what we're going to be looking at is we're going to be looking at this triangle in order to find the length of x. And you might be asking, well, how are we going to find the length of x from this triangle? This triangle has nothing to do with x. But as you'll see, it actually does have a lot to do with x, because take a look at this length CD. Because ABCD is a parallelogram, AB is equal to CD. But remember, you see AB over here, it's equal to 6 plus x. So CD is equal to 6 plus x. Now, furthermore, how can we find DF? Because if we can find DF in terms of x, we could solve for x, actually. So how are we going to find DF? What we're going to do is we're going to look at this green segment AZ and this segment BX, which has length lowercase x, and from that we can actually find the length EB, which is equal to DF. Because remember, this is a parallelogram, you've got rotational symmetry, so this length EB is equal to the length DF. They're both extensions of one of the bases. So DF is equal to EB. So how are you going to find EB? Well, if you take a look, AEXZ is a rectangle because it's got 4 90-degree angles. So AZ is equal to EX, But since AZ is 6, EX is 6. So you can find this length over here. It's 6 minus X, right? Because these two lengths have to add up to 6. So EB is 6 minus X. So DF is 6 minus X as well. And now you have your three sides of this triangle CDF, and you can solve for X in terms of, well, you can just solve for X. So you have Pythagorean theorem, 6 minus X squared plus 6 root 3 squared is equal to 6 plus X squared. And if you expand this out, 6 minus X squared minus 12X plus 36 plus 6 root 3, which is squared, which is 108, is equal to X squared plus 12X plus 36. Now, a bunch of stuff cancels out. This X squared cancels out with this X squared over here. You can subtract 36 from both sides. You are left with negative 12X plus 108 is equal to 12X. 108 is equal to 24X. And 9 over 2 is equal to X. Therefore, this length over here is equal to 9 over 2. So your entire base would have length. This entire base has length 20 plus 9 over 2, which is 24.5. So your base is 24.5. And we are running down the home stretch because our area was base times height. Base is 24.5, height is 6.3. Multiply them together. What are you going to get? You are going to get 49 over 2 times 6 root 3. You can cancel out a factor of 2 from the numerator and the denominator. You're left with 49 times 3, which is 147, square root of 3. So your answer is 147 plus 3, which is 150. And we are done. Thanks for watching, and I will see you next time.